Hello guys, I hope I'm audible to all of you right now. Welcome back to this amazing platform of beauty learning, and today we are back again another important topic. And today our topic is basically again gonna be on functions, right? So this is the second continuation lecture that I am taking for the topic of functions, and this is gonna be like a part 2 that I have taken previously. Okay, so previously I have already taken the part 1 for functions, and this is a new series that we are starting on live on this particular platform, especially for the upcoming JEE mains examination, which is going to be in the year 2026. Okay, so all the students who are preparing for the upcoming examinations, who are currently in class 11th or class 12 and are currently preparing for the IIT JEE or the JEE mains examination or any other state competitive examination, they are very much uh, very much excited on this particular series. So we are back again with this important series, and in this particular series we are going to go with each and every chapters with the flow, and I'm going to discuss all the important topics, all the important questions, and along with that we are also going to practice some of the important mock test as well. Okay, and I started with the I started with functions right now, and with the functions, and I wanted to start with calculus and all the portions one by one. And so we started with functions. Functions is very important chapter for especially for the JE portion. That's why I'm starting with functions from now. Okay. And if you look at this particular chapter has a lot of important weightage for the examination. That's why function is again a very important chapters to start with. Okay. If you look at chapters like limits, continuity, differentiability, differentiations, methods of derivative, applications of derivatives, integrations, area under the curves, a differential equation, all of those chapters that you have in calculus are all related with the very important chapter, that is set, relations and functions. So I'm discussing the functions portion right now. Okay, and once we are done with that most important chunk of the preparation for your maths, especially the calculus portion, I'm going to discuss after that. I'm going to start with the algebra portion as well. Okay, so stay tuned. If you're someone who new to this platform, please don't forget to subscribe to the channel and click on the bell icons to never miss any upcoming notification. Sajid, hi Sajid. Sajid 1000, hi. Okay, so let's get started on this particular thing. Okay, before I start this series, I want all of you to please have, or you might also download the PDF version of your NCRT as well as NCRT exemplar, right? Because all the questions that we're going to discuss in this particular sessions are not going to be from the NCRT exemplars, but it is very important to also revise and along with also study the NCRT and the NCRT exemplar questions along with the session we are going to discuss over here. Okay, so these are the important textbook that you need to follow if for in especially if you're preparing for JEE examinations. Okay, so with this particular note, let's get started. And again, another very interesting and helpful news to all of you. So students who are currently in class 11th or class 12 and they are looking for any particular online tuitions, definitely you can contact us on this particular number. We are going to launch our live batches very soon, and the prices for the live batches is just starting at rupees 999. Okay, so please contact on this particular number if you want to get any more information about the content, how will the batches will go on, and any such questions. You can always contact us on this particular number. Okay, you can also join our Telegram channel. The link is in the description. Okay, join the Telegram channel. The link is in the description. Okay, so you can join the Telegram channel. The link is in the description box. Okay, so in the description of this particular live session, you can find the Telegram channel link and you can join it to stay tuned with the upcoming notifications on the batch related informations as well as how we are going to proceed with the batches, right? So also I'm going to discuss, also along with that I'm going to discuss like different mock test, different practice strategies, and so stay tuned for that. If you haven't joined the Telegram channel till now, please join it. And if you are new to this particular platform, I would definitely say that please subscribe to the channel and help us grow as well. All right. All right, so with this part, let's get started. Okay, so before we start, and I want to discuss something about the another more important topic, that is the permutation based problems in functions. Okay, now this is a particular part where I have seen students definitely have a lot of difficulty, right? So what I'm going to do right now, I'm going to break down that particular difficult concepts for all of you so that you don't have any problem, and I'm going to break the problem into step by step manner so that you can easily get over the problem and can solve any questions that can come up in your JEE examinations or any other competitive examination. Okay, so the problems that I'm going to talk about right now is the counting the number of functions that is possible from set A to set B. Okay, right. So let us say I'm basically discussing a function f which is going from set A to set B, where A is our domain and B is our codomain. So let us try to divide and separate the problems into two different sections. And first of all, I'm going to talk about the first case, the case number one, when both the set A and B contains an equal number of elements. Okay, so I'm going to first of all talk in the condition when the cardinality of set A is equals to cardinality of set B. Okay, so when both of the set A and B has the same number of elements, I'm going to talk about that particular condition, that whenever the both of the sets is having equal number of elements, what is the conditions. Okay, so when this particular set A and set B has the equal number of elements, the total number of functions can be easily done by n to the power n. Okay, so it's a very simple thing. If the number of elements is n and both of the same element, the total number of functions can be simply given out as n to the power n. Okay, and this n to the power n is very simple to find out, even if so I hope you know all this, that the total number of functions that can be possible from set A to set B is basically given as cardinality of B whole to the power cardinality of A. Okay, so you just need to apply this particular form and this formula over here in order to get it. Okay, and this formula comes from the counting principle. Okay, so if you look at any of the element in A, the A in any element in A has three options. Similarly, B also has three options, and similarly C also has three options. So that basically means any elements in A has number of elements in B as their options. Okay, so A has three options for image, and B also has three options in image as in given in the picture over here. So the total number of functions can simply be given as 3 to the power 3. Right, so it is very simple from, I hope you know this. Okay, so when number of elements, so this is the total number of functions. Now interesting things comes up when I ask you to find and calculate the number of 1-to-1 functions or 1-1 functions. Okay, so if I ask you about the 1-1 map, that can be possible, which is also very similar, because if you look at the 1-1 map over here, so if the number of elements is 5, then if the number of elements in B is 5, then any element in A will obviously have 5 options. But once A has chosen up any element or any image in the range, or the, I should write it as in codomain. Okay, in the codomain, then then B will have, then the other element of A will have n minus 1 number of choices in the codomain, because it has to be a 1-1 functions. Okay, so for 1-1 function, this particular condition has to be satisfied. Therefore, if A has 5 options, B will have 4 options, and C will have 3 options, D will have 2 options, and E will have 1 option. So that basically makes total functions. So this basically gives us our total functions, which is basically equals to n factorial, or I should write it, since n is equal to 5 over here, so it's just equal to 5 factorial. Okay, so it is going to be equal to 5 factorial because it has 5 options, 5 into 4 into 3 into 2 into 1, which is basically nothing but 5 factorial ways, right? So therefore, if I need to count up for n number of elements, if there are n number of elements and the number of 1-1 functions, if I need to count it up, the number of 1-1 function is going to be equal to simply equal to n factorial. Similarly, if I need to count for many one function, so many one function is very easy. You count the total number of functions and then subtract it from the 1-1 functions. That will generate you all the many one functions possible, right? So that is very simple. Now, another interesting case is basically when you need to count for number of onto functions, when you need to count for number of onto functions. Now, the interesting thing over here is that in case of equal number of elements in the domain and the codomain, the onto functions are the same as the 1-1 function. So the number of 1-1 function is same as the onto function. So therefore, here also number of onto function, we are also going to have it as n factorial. I hope this part of this thing is clear to all of you. Is this part clear to all of you? Please do let me know if this part is clear or not, right? So far, so good. Okay, great. So far we have understood the number of onto functions can now be given as n factorial when the number of elements in domain and codomain are equal. Now let us come to the different case when the number of elements in A of the codomain is more than that in B. So if the number of elements in A is more than number of elements in B, the row number functions can be simply given by number of codomain to the power number of domain, right? That is very simple. That is you all know. But in this case, the interesting thing will be the number of one function will be 0. There will be no one function that is possible. And similarly, the number of onto functions can be calculated by using simply the group formation method. Okay, so I will just give you a simple example to illustrate the saying. So as you can see over here, let's say let's say I have number of elements in A as 5 and number of elements in B as just as 4. Okay, so let us say that so in order to calculate for onto functions, okay, so in order to calculate for onto functions over here, so if I need to calculate for onto functions, so what I can see that if I have to make it an onto function, then the range should be equal to the codomain, right? Then I should have range should be equal to the codomain, right? So I should have our range to be equal to the codomain over here, right? Now, how we can I satisfy that the range should be equal to the codomain? That means these four elements has to be distributed among these five uh, identities or people over here. Okay, so I can use the group division. So it is basically like I have to distribute 5 elements of A among 4 elements of B. So how can I do that? So I have to make group formation. So I can write 5 and I can make some groups like 2, 1, 1 and 1. So this is the only possible way in which I can make a group of 4 to divide these 5 objects. Okay, so let us say then this, if I count it by permutation, I know it that by permutation this will be like 5 factorial divided by 2 factorial divided by 1 factorial whole to the power. So this will be like 1 factorial whole to the power 3 whole to the power 3 into 1 upon 3 factorial, and then this all can be permuted in 4 factorial ways. So there are 4 different identities, so I can write it as and then multiplied with 4 factorial. So this will generate me the number of cases I can make or distribute the groups. Okay, I can distribute the groups. Okay, so this is a way how you will need to calculate for the onto functions. Now, another interesting case comes up when the number of elements when the number of elements in the codomain is more than the number of elements in A. Right. In this case, again, pronoun function is the same. But if I need to calculate for injective map or one map, then it is very simple. So what I'm going to do is that if I have 4 elements in A and 6 elements in B, so out of this 6 element out of the 6 element in B, I will just select 4 of which they will be the images, right? And then I will just distribute in among these four ways. Okay, so this will give me, or 4 factorial ways, this will give me the number of one functions. Okay, so this will give me the number of one functions possible. Okay, so I hope this part is clear to all of you. And similarly, now in this case, when the number of elements in codomain is larger than the number of elements in A, you won't be having any onto functions. You won't be having any onto functions. So there won't be any onto functions. Okay, I hope this discussion has been clear to all of you. I hope this discussion is clear and to all of you. I use thus PW is best. Yes, PW is best. Anything is best. Okay. Okay, I use thus. Are you clear with this concept? Okay, anyone is best. Okay, PW is best, everyone is best, but everyone is best only and until when you understand the concepts. Okay, is this part clear to all of you? Is the solution clear to all of you? Please let me know. Please let me know if the solution is clear or not. Is this part clear to all of you? Now, why I'm asking this particular thing, because we are going to discuss the JEE mains previous year questions, and also we are going to discuss the important JEE mains questions that can come up in your paper, where it involves permutations or counting the number of functions that can be possible from set A to set B. Okay, so let's start with the very first question over here. Okay, now before I start, I would again ask all of you to please go through this particular forms and go to this particular concepts over here, and let me know if you have any questions over here or not. Okay, so if you need to be clear with this before we can get started on the things, because it is very important to have an important understanding over the concepts, because once your concepts are clear, you can solve any types of questions. Okay, so I hope this particular part is clear to all of you. So let's start and try to solve the very first question over here. Okay, so the first question that I'm taking up is from a previous year question of JEE Mains, and let us try to see how we can go about solving this problem over here, right? So it is said that consider a function going from real number to a real number, where domain and the codomain are both the real numbers, and it is said that your function f of x is defined as 2x upon square root of 1 plus 9x square. Okay, square root of 1 plus 9x square. Now it is said that if the composition or the composite function f of f of and so on, f of x, such that this composition is basically given as 10 times, this composition is basically given 10 times, and that is defined as 2 to the power 10 into x whole divided by square root of 1 plus 9 alpha x square. Okay, if this is how the composite function is defined with this given function f of x, it is asking you to find the value of square root of 3 alpha plus 1. Okay, so that's a interesting problem over here. So let us break this problem into smaller part, and let us try to go step by step. Okay, so first and foremost, if I find it out, the f of x, that is what I can also call f of x. Okay, so just one composition, so that can be given as 2 times of, so in place of x I'll put f of x, and then divided by square root of 1 plus 9 times of f of x whole square over here, which is equals to 4x divided by square root of 1 plus 9x square whole divided by square root of 1 plus 9 times of 4x square divided by square, yeah, the square will be not be there. Okay, so oh, I just yeah, correct. Correct. So this will be this, there won't be any square root over here, and then this is going to be like 1 plus 9x square, 1 plus 9x square, right? And then from this part over here, we are going to get this result as equals to 4x upon square root of 1 plus 45 x square. So therefore we're going to get this particular solution as 1 plus 44x by 1 square root of 1 plus 45 x square, right? This is our first composition. Similarly, if I find out the f of x, then this particular result is going to be equals to, so if you just go on the same notation, this result is going to be equal to 8x upon square root of 1 plus 21 times of 9x square. So what is more interesting to note over here is that it is basically 5 times of 9x square. It is basically 21 times of 9x square, right? So similarly, if I go on in the same notation, f of and sorry, f of, so if I go on 4 times, right? So if I go on 4 times, this is going to be equal to 16 times x of 1 upon square root of 1 plus 85 times of 9x square. Okay, 85 times of 9x square. So you can do it very simply, just do those calculations and you can get it. Okay, so what you understand is that, so if I do it 10 times, your given part over here, that is alpha over here, this, because you can see this is 4 times, so this is basically So this 16 is coming as 2 to the power 4. Okay, so when there is 4 times, it's 2 to the power 4. So similarly for 10 times, it will be 2 to the power 10. But what is more interesting is to note at this alpha over here. So alpha is the 10th term of 1, 5, then we have 21, 85, and so on. Okay, so I need to find out of this particular sequence. So over here you can look over this particular thing or this sequence over here, and you will find out that I have to find out alpha, which is the 10th term of it. So it is a kind of an progression as well. So what I will suggest is that if you just be creative enough to understand this one I can write as 2 to the power 1 whole square minus 1 by 3. Then 5 I can write as 2 to the power 2 whole to the power 2 minus 1 upon 3, right? Similar 21 I can write as 2 to the power 3 whole to the power 3 minus 1 upon 3. So on I can go out, and therefore the 10th term will be like 2 to the power 10 whole to the power 10 minus 1 upon 3, right? So this is going to be your alpha. So this thing is going to be equal to alpha. Therefore 3 alpha plus 1 and square root of it is going to be equal to 2 to the power 10 whole to the power 10 and then square root of it, right? uh, sorry, very sorry, this is not going to be, this is the square of that, right? Correct, this square of it, right? This is square and this part is also square, yeah, correct. So this is going to be like 2 to the power 10 whole square and then square root of it, which is going to be equal to 2 to the power 10, which is going to be simply equal to the power 10, and the value is equal to 1024, and therefore the simple value to this question is going to be equal to 1024. Okay, 1024 is going to be the correct answer. 1024 is going to be the correct answer. I hope this particular part of the solution is clear to all of you. I hope this solution is clear to all of you. Right? Is this part clear to all of you? Is this part of the solution clear to all of you? Please let me know. Okay, this was a very simple, interesting problem. Okay, if you go on doing the problem step by step and you break the difficult problem into smaller parts, then the question is going to be very, very simple. Okay, is this solution clear to all of you? Please let me know if this part of the solution is clear to all of you or not. Right? It's a very interesting problem, and these kinds of problems can definitely come up in your JEE Mains examination as well. Okay, so please don't forget to make sure that you understand these problems and keep a hold over these concepts. Once you are clear with the concepts, you can definitely go on solving the questions as well. Okay, all right. So that's being said, we can move to the next problem as well. Okay, so I hope there is no more questions in this problem. So if this particular problem is clear to all of you, let's move to the next problem. Okay, so here we go with the next problem, and here we have to count. Here it is said that there is a set A and P of A denotes the power set. So we all know that power set basically denotes the number, all the is a set of all the subsets. Okay, so if I talk about the power set over here, so power set of A, so power set of A is basically, so PA denotes the power set of A. So if I now try to calculate the number of elements in the power set, it is basically given as the number of elements in A, 2 to the power number of elements in A. Okay, simply as 2 to the power number of elements in A. Now it is said there is a function which is going from set A to the power set of A such that A belongs to f of A. Okay, for all A belongs to A. Okay, so if this condition is said, m to the power n and m and n are both natural number, so you have to find out the so it is said, okay, so it is said that A belongs to f of A for all A belongs to A is, okay, so the number of functions, okay, number of functions where this particular condition is satisfied is basically given as m to the power n, where m and n are both natural number. Okay, so you have to find out m is least. Okay, and m is least, then you have to find out what is the sum of m plus n. okay, with having the minimum value of n. Let's try to see how we go about solving this problem. So if I look at this statement over here, that is said that A belongs to f of a. So A belongs to f of a, that means A will be connect. A will connect with subset which contain the element A. So A will connect only with the subset which will contain the element A. Then only I will have A as a part of f of A, right? So therefore total number of options for one. So let us say I take up any element from A. Let us say I take up element 1. So total number of options for 1 will be basically 2 to the power 6, right? Because for any options I will have 2 to the power 6 subsets possible which will contain the element 1, right? Similarly for the other elements, for the other elements also, I will have a total options as 2 to the power 6 into 2 to the power 6 into 2 to the power 6 into 2 to the power 6, okay, into 2 to the power 6, okay. So we will have total of 2 to the power 6 whole to the power 7, okay. Okay, so we will have 2 to the power 42 over here. So we will have 2 to the power 42, right? Now it is said that it is basically given as m to the power n, where m is the minimum. So minimum value is basically m is basically equal to 2 and n is basically equal to 42. So therefore m plus n is basically equals to 44. So m plus n is basically equals to 44. So m plus n is basically equals to 44. I hope this solution is clear to all of you. Okay, so it's a very simple straightforward problem. So it is a pretty straightforward problem, and I hope this solution is clear to all of you, right? Is the solution clear to all of you? Please let me know if the solution is clear or not. It's a very straightforward problem. In this problem, we have to make sure that A basically belongs to the functional output, right? So that can only happen when A is part of that particular subset. So for every options, I will have to do the power 6 different subsets possible, right? So I just connected that particular idea, that considering A, so if I have one element as A, what are the possible subsets that I can generate from with A, right? So there are 2 to the power 6 solutions, right? So therefore for 1 there are 2 to the 6, and similarly for 2 we will also have 2 to the power 6, for 3 we will have 2 to the power 6, so and so on. For all the 7 elements we will have 2 to the power 6 options, and in total if I join all the 2 to the power 6 options, this is going to be equal to 2 to the power 42, and that is basically given as the total number of functions is given as m to the power n, right? M to the power n over there, right? So from there I got to this understanding, and there I connected the solution, and with that I got the value of m plus n is equal to 44. Is this part clear to all of you? Is this part of the solution clear to all of you? Please let me know if this part of the solution is clear or not. Right? In case you have any questions, you can always put in the live chat, or you can always comment me after the live class is over. Okay, I will love to answer your wonderful comments. Okay, but please don't make this mistake that even if you have a doubt, you're not asking, that you are afraid to ask or something like that. Okay, please feel free to ask any of the questions apart from the stupid questions that you are having, right? So in case your question is very much related to technical background or technical subject, then definitely ask it. Otherwise I will not entertain any more stupid questions though. Okay, but yeah, always yeah, love in case you have any questions, always comment up. Okay, always put your comments in the comment sections. All right, so with this, let's move to the next problem. Right, the next problem is another very interesting problem. So in this problem, what you see over here is that I have to count for the number of so if you look at the problem over here, so I have to given a particular set A and set B. So if you look over here, you have a given set A and set B satisfying with the following condition, that your function going from A to B is satisfying the following condition, that is f of 1 plus f of 2 is equals to f of 4 minus of 1, right? So if I have this particular condition, this question is quite interesting, that in order to solve this problem over here, I have to just go over doing the cases by case or matching the cases. Okay, so what I can see over here, it is said that you have to choose the functional output such that f of 1 plus f of 2 plus of 1 is equals to f of 4, right? So I have to fulfill this particular condition over here such that this particular condition is fulfilled over here, right? So in order to fulfill this condition, and then you have to count up that how many functions are possible with this particular condition over here, right? Right, so let us see. So given elements of A and B, let us first observe the condition, that is f of 1 plus f of 2 plus 1 is equals to f of 4. So sum of f of 1, f of 2 and 1 is equal to f of 4. Since f of 4 is a value in the set B, so it can only take elements from 1 to 3 and so on up to 6. Okay, so it can only take up elements in between these numbers, right? So now let us analyze the number of functions for each values of f of 4 from 3 to 6. Okay, so let us try to analyze the values from 3, 4, 5 and 6. Okay, first of all, let us analyze these four values. Okay, so if I take up, so let us try to make some cases, that if I take up f of 4 is equal to 6 and then f of 1 plus f of 2 is equals to 5, then this particular condition will satisfy. So which can be done as, so if I choose f of 1 as, so function of output as 1 comma 4 or maybe 2 comma 3 or maybe 3 comma 2 or maybe 4 comma 1, right? So each of these four cases, f of 3 and f of 5 can take up 6 values from the set B, and the remaining, and therefore this particular thing will result in, so when f of 4 is equal to 6, this particular case will result in total number of function as 4 into 6 into 6, which is basically equals to, sorry, 144, which is basically equals to 144, right? Similarly, if I take up f of 4 is equals to 5, and in that case I have to have f of 1 plus f of 2 as equals to 4, so which will result in the following as 1 comma 3, 2 comma 2 or 3 comma 1. Okay, there are three options in this case, and then 4 and 5, oh sorry, 3 and 5 will take up any of the six choices. So therefore the total number function in this case will be 3 into 6 into 6, which is basically equals to 108. And similarly, if I focus on the functional output of f of 4 is equals to 4, in this case I will have f of 1 plus f of 2 should be equal to 3, which will result as 1 comma 2 and 2 comma 1 as the following possibilities, right? So therefore in these two cases I will have either then in these cases, the two cases, that is f of 3 and f of 5, can again take these 6 values. So therefore this will be like 2 into 6 into 6, which is basically equals to 72 functions from this particular case, right? And similarly, if I focus on f of 4 is equals to 3, then I will have f of 1 plus f of 2 should be equals to 1, which is possible, which will satisfied only for the case when we have 1 comma 1, right? When f of 1 and f of 2 is also equal to 1, right? So in this case, the function f of 3 and f of 5 can also take 6 values on the set V. Therefore, the number of functions that can be possible of this is basically equal to 36. Okay. So therefore, adding all these functions up will be resulting the following cases, and therefore the total functions possible, the total functions possible the total functions possible here will be equal to 36 plus 72 plus 108 plus 144, which is basically equal to 360 functions. Therefore, the total number of functions that can be possible with the following condition as satisfied will be equal to 360, will be simply equals to 360 cases. Okay, so therefore the total number of functions are going to be equal to 360. Okay, I hope this solution is clear to all of you. I hope this solution is clear to all of you, right? Please let me know if the solution is clear or not. Please let me know the solution is clear or not. Okay, so this is very interesting problem, and also you have to understand how you make cases and count for the number of choices. Okay, not always you're going to face up the questions that is directly coming out from the formula. Okay, so it might be happen that you know the formula, but still you're not able to form the questions or solve the question. This is basically very possible because you don't know the main underlying concept of permutation and combination, and then you have to apply the condition. Okay, so based on the condition, you have to count the total number of favorable or possible cases. Okay, so that is something that you need to learn now in order to solve these problems. Okay, so I hope this particular part of the solution is clear to all of you. So with this part, I would like to leave this particular problem as a home problem for all of you. Okay, so I hope this class was effective enough to make sure that you understood these questions of permutations and combination for functions. Okay, now I want to take this class especially on this particular topic of permutation and combination in functions because it's a very important topic, and I have seen there are a lot of questions that are coming up from this particular topic, especially for JEE Mains and JEE Advanced. Okay, so keeping in mind those particular thing, I want to give this particular problem as a homework problem. So please let me know the answer of this particular problem in the comment section. Okay, please comment homework number 1, answer is this. Okay, answer is this. Okay, so this is how you're going to comment after the live class is over. Okay, so please make sure that you solve this problem and try to get the solution. In case you are not able to solve it, please make sure, please feel free to ask for the solution. Okay, in case you are not able to solve it, please feel free to ask for the solution of this problem in the next upcoming classes. Okay, and I will be very happy to answer all of your questions in case you are not able to solve it. In case you are able to solve it, definitely comment me in this particular video after this live class is over in the comment sections. Okay, so saying all this particular part, I hope this session was useful for all of you, and hope to see you soon in the next upcoming content. So with this part, we are almost done with the concepts of functions, but again, I'm going to take up a lot of questions. As you all know, this is a important series, and this is a new series, okay, that I'm starting up. Okay, so now I have more time, so I will be solving a lot of questions with all of you, and we are going to come up live every day on this particular platform. So if you haven't subscribed to the particular channel, don't forget to subscribe to this channel and hit the bell icon to never miss any upcoming notification. And in case you like this video, definitely like the video and comment with the answers and comment with all of your thinking or your thought process or any feedback that you want me to focus on and continue for the upcoming sessions. And if you like this video, and you please don't forget to share it among your friends and among those people whom you think they need this particular video right now. Okay, so these videos are just for free on YouTube, and you can definitely access this video at any time with a stable internet connection. Okay, so by saying all these things, I hope you enjoyed the videos, you enjoyed watching these questions. Okay, and so watching the solution and also going over the concepts. Okay, so with this, let us end this video over here.